Howdy y'all, Stock Warden here, back with another video. In today's video we're looking back at Sun Hydrogen Incorporated, and they have just come out with a update on their Austin pilot demonstration for their new technology that they've been putting out. So they have their new and improved revised 1.92 meter square modules, which are including an inclined field configuration that are installed to support coating, catalyst, housing, balance of system, and manufacturing refinements. So to just touch on Sun Hydrogen and what they are and what they're about, if you have not been up to speed and this is the first time you're on the channel, Sun Hydrogen is the developer of a breakthrough technology to produce renewable hydrogen using only sunlight and water. Today, they announced the installation of their upgraded 1.92 meter square hydrogen modules at the company's pilot's demonstration system at the University of Texas at Austin's Hydrogen Proto Hub. So the newly installed modules incorporate multiple engineering improvements identified during the initial outdoor operation, including revised reactor housing, which is designed for inclined operation, along with improved catalyst integration, enhanced protective coatings, and expanded instrumentation. So the upgrades represent the next phase in Sun Hydrogen's staged pilot program, which is designed to validate module performance while advancing manufacturability, along with a system reliability under real-world operating conditions. So these revised reactor housings are designed for operation at an approximate 30 degrees fixed incline, which is close to Austin's latitude, providing a practical solar field configuration for evaluating year-round sunlight capture and outdoor performance. So the inclined configuration is also designed to support future improvements in gas collection and separation within the reactor housing. Future commercial installations may employ different mounting angles depending on geographic location, site constraints, structural design, and project requirements. Operating upgraded modules alongside earlier generations allow Sun Hydrogen to directly compare the performance, durability, and operating characteristics under identical outdoor conditions, so the resulting data will guide future module design, manufacturing methods, and system architecture. So temperature remains a key engineering focus of the Austin pilot. So while laboratory testing allows temperature and illumination to be tightly controlled, the outdoor operation exposes the system to continuously changing sunlight, ambient conditions, and wind throughout the day and also across all various seasons. These temperature variations influence multiple parts of the reactor differently, so higher temperatures generally reduce the semiconductor voltage while often improving catalyst reaction kinetics. So the objective is therefore not simply to maximize or minimize operating temperature, but rather to enlarge the practical operating window in which the semiconductor absorber, catalyst, protective coatings, gas management system, and balance of system components operate together with maximum efficiency, durability, and reliability. So the data collected from the Austin's pilot will be used to continue optimizing for future reactor designs, for long-term outdoor deployment. Sun Hydrogen has also expanded the instrumentation and monitoring capabilities of the Austin pilot, enhanced sensing and data acquisition systems provide greater visibility into the reactor performance, including gas composition, monitoring to assess the hydrogen output under real-world conditions, and enable higher confidence analysis of long-term outdoor operation. So with all of that, you have Dr. Seed Mubin, which is the Chief Technology Officer for Sun Hydrogen, ended up coming out and saying that the pilot system is revealing what the laboratory testing cannot, and the upgraded modules are reflecting the lessons from our initial field deployment and bringing us another step closer to a durable, manufacturable technology for real-world hydrogen production. So, and with separately from Sun Hydrogen, a additional upgraded semiconductor module produced through Sun Hydrogen's manufacturing development program with CTF Solar have arrived at the company's Iowa facilities. So these modules will be used to evaluate manufacturing reproducibility and production yield, along with field performance across a larger population of manufactured modules. So this evaluation includes the uniformity and repeatability of protective coatings across production runs. So the work is intended to demonstrate that recent design improvements can be produced consistently and translated into scalable manufacturing processes. So then Tim Young ended up coming out and making a statement with all of this as well, saying that our pilot program is about more than just validating performance. It is about building the engineering and manufacturing foundation needed to move our technology from successful prototypes toward commercial deployment, and that Sun Hydrogen will continue collecting their long-term operating data from the Austin pilot throughout the coming months. So insights from the program will guide the next generation of module design, manufacturing processes, system integration, and architecture as the company advances towards the larger scale field demonstration and their commercial deployment. So that is their full statement that they have put in for their full technology update on the Austin pilot demonstration program. So they are definitely in the right spot to be able to start trying and stress testing these panels, because if you look at the weather that comes through Austin, Texas, you can see in the summer highs that go up into the up to 120 plus degree ambient temperature, and knowing how temperature affects these modules is going to definitely do a full-blown stress test whenever it comes to high temperatures, because Austin gets to be one of the hottest places in the state of Texas. So then if they can make them work and handle and still be able to produce a high margin within Austin, Texas, then the next step would be something straight out of a desert, be it your Phoenix, Arizona, or somewhere into Nevada. So, but with them already being in a place of extreme for Austin for heat, they're also getting a huge deal of information and data, because the state of Texas is in its full-blown rainy season right now. So there have been monsoons constantly going over almost the entire state of Texas. Just East Texas alone has seen almost 40 inches of rain just this year alone. So, and since Sun Hydrogen had started their pilot program at UT Austin before the turn of this year, they're able to see just how much hydrogen their modules are putting out under cloudy skies, under rain, and low sunlight. So to be able to see those numbers come in as well is something that's going to be great to see whenever those modules are going to start pushing the limits of how much they can produce with the least amount of sunlight possible in these real world conditions, because the only true downside of solar is nighttime, but you also have the cloud coverage, rain, and different things in these outside elements that can definitely construe and change a lot of what their original inside testing facility numbers were. So that is definitely something that I'm ready to see for their next upgrade system update that they have coming through, because now that they know where these hot temperatures are coming in and changing things, along with them having different issues with how much hydrogen are they going to be able to produce under this different type of inclement weather that the state of Texas is definitely known for, then you can also turn around and think that in the next 6 months we will be looking into sub-freezing temperatures. So then you'll be looking at also testing these panels in the colder environments with sunlight as well. So then the semiconductors and the electrodes will be doing good, but how is the catalyst going to fare whenever it starts to freeze? So, but as it stands, Sun Hydrogen is just having to do small tweaks at this point and being able to start streamlining their panels into getting a better manufacturing process. So every step of the way that they improve, they are 100% gearing every little step of the way into how can they readily commercialize and mass produce these panels all at one time. So that's also something that's great about Sun Hydrogen, because not only are they entering into this real world testing phase and they are getting very good at making their panels even better, tweaking little things here and there to make them work in the real world aspect of things, that they're also being able to continue keeping their eye on the prize of when they do go to full-scale commercialization, just how fast they're going to be able to pump out these upgraded and new and improved modules without having any problems with backstock and or having to consistently change old ones out for newer and better modules. So that is everything that I have on Sun Hydrogen. So I hope y'all enjoyed the video. Don't forget to like, comment, and subscribe. And as always, if you have a stock that you have been looking at or have been thinking about getting into that you want a little bit more research on, don't hesitate to drop it down in the comments below. I would love to be able to do another stock and bring it out to you guys as well. So we're definitely growing this channel. I think I am up to about a dozen stocks that I'm covering at this point right now. So with all that being said, this is the Stock Warden riding off. So y'all come back now, you hear?